Hello guys and welcome back. Today we're going to talk about flow sensors. The main categories for flow sensors in the industrial field are differential pressure, vortex measurement, Coriolis type flow sensor, ultrasonic, and electromagnetic. Today we're going to talk about the electromagnetic type. Flow is an essential measurement in many industrial processes. In the typical application, a flow sensor is used to determine the volume of liquid or gas that passes through a pipe in liters per second or gallons per minute. Modern sensors incorporate electronics that can correct for varying pressure, temperature, density, nonlinearities, and the characteristics of the fluid. These sensors may provide a local readout but usually will also send a signal to a remote indicator or SCADA system. Electronic sensors do not measure flow directly. They rely on another sensing method to infer the flow rate. Popular types of electronic flow sensors are differential pressure, thermal, target, paddle wheel, and magneto-inductive. We also have the vortex measurement sensor, Coriolis meter type sensor, ultrasonic and electromagnetic type sensors. The magneto-inductive technique is used to measure the flow of conductive liquids. According to Faraday's law of magnetic induction, current is induced into a conductor as it moves through a magnetic field. The amount of current induced is directly proportional to the velocity of the moving conductor. A conductive liquid passing through the flow sensor body acts as a conductor. The sensor contains a set of coils that generate a magnetic field. Electrodes mounted on the sensor body conduct current. The current magnitude is proportional to the flow rate. This type of sensor has no pressure drop and no moving parts. It is not affected by changes in temperature, pressure, or density, and can handle fluids with contaminants. Each sensor type is available in a variety of sizes and mechanical configurations, with or without a local display. Most sensors convert the flow into process output signals of 4 through 20 milliamps, or 0 through 10 volts DC, or 0 through 5 volts DC, pulse or frequency. A switch output can often be added to a control external equipment based on a flow set point. So what's behind the measurement of flow sensors? The measurement principle states that Faraday's law of induction states that a metal rod moving in a magnetic field induces electrical voltage. This dynamo principle also governs the way electromagnetic flow meters work. As soon as the electrically charged particles cross the artificial magnetic field generated by two field coils, an electric voltage is induced. This voltage, tagged by two measuring electrodes, is directly proportional to the velocity of flow, and thus to the flow volume. Magnetic field is generated by a pulsed direct current with alternating polarity. This ensures a stable 0 point and makes the flow measurement intensive and multiphase or inhomogeneous liquids, as well as low conductivity. Advantages at a glance. The measuring principle is virtually independent of pressure, density, temperature, or viscosity. Even fluids with entrained solids can be metered, or slurry or cellulose pulp also can be measured. High degree of measuring reproducibility and long-term stability. Popularity of magnetometers across innumerable sectors of industries continue to be unabated. Further proof of the worldwide success that this measuring principle has been enjoying for more than 15 years. Magnetometers can be used to measure all electrically conductive liquids, with or without solids. Example, water, wastewater, sludge, slurries, pastes, acids, alkalides, juices, and fruit meshes. The rule of thumb for magnetometers is anything that can be pumped can also be measured. A highly valued trade in measurement technology. Typically tasks include measuring and monitoring continuous flow rates, filling and dosing, as well as applications in custody transfer. In the industrial environment, magnetometers are primarily used in water management and in the processing, life sciences, and food industries. In tunnel construction and mining, robust magnetometers are often the only option for measuring highly abrasive or slurries with entrained solids, sand water mixtures, fill materials, or bulk solids with required accuracy. There are different brands and different types and different models of electromagnetic flow sensors, but the principle behind them is basically the same. The function of an induction flow meter is based on the Faraday's induction law. The meter sensor consists of a non-magnetic and non-conductive tube with two embedded measuring electrodes to pick up the induced voltage. To create an alternating magnetic field, two coils are fitted into the tube in parallel with the plane defined by active parts of the measuring electrodes. Now, if a conductive liquid flows across magnetic field E, voltage U will appear on the measuring electrode proportional to the flow velocity V and the conductor length I. Therefore, U equals V times I times V. As the magnetic flux density and distance between the electrodes are constant, the induced voltage is proportional to the liquid flow velocity in the tube. The value of the volume flow rate can then be readily determined as a product of the flow velocity at square section of the tube. Q equals V times S. Technical description. The induction flow meter consists of a sensor through which the measured liquid flows in an electronic unit where the low-level signal from the sensor is modified to a standardized form suitable for further processing in various industrial electronic devices. The output signal is proportional to the volume flow rate of the measured liquid. The only factor limiting the application of induction flow meters is the requirement that the measured liquid shall be conductive and non-magnetic. The induction flow meter can be designed either as a compact device or with the sensor separated from the associated electronic unit. In the former case, the electronic unit is fitted directly onto the meter sensor. In the latter case, it is connected to the sensor by special cable. The sensor design should take into consideration the type of measured liquid and its operational parameters. To facilitate fitting into the liquid piping, the sensor can be provided with end flanges, threaded or it may be of a flange-less design. The supply voltage types of output signals and communications interface can be selected according to the customer requirements. The basic configuration flow meter includes two insulated passive binary outputs, each with an opt coupler including a transistor output. Insulated RS-485 communications, dry relay, 4 through 20 milliamp output, and the USB communication interface. The USB interface is not insulated as it is used for factory calibration purposes. Optional accessories to the basic configuration are input 1, output 3 for batching, or with galvanic separation. And that is it today for magnetic flow sensors. Join me tomorrow for part 2 of flow sensors. And thank you for watching, and I will see you all later.